today's lesson, we will be talking about solving equations with a variable on each side and those involving grouping symbols. Okay, so this is kind of taking the last few learning targets and just kind of stepping them up a bit. So I have 6 examples here of us just kind of going through all the different things that you can have happen when you have variables on both sides, and then involving some grouping symbols in there, and kind of the process and what you should be thinking about when you are solving these. Okay, so let's go ahead and get started. So example 1 says 2 plus 5k equals 3k minus 6. So when I look at when there's variables on each side, I like to think about the like terms that are possible here. So and it doesn't matter what you do first. You can put your variables together, because notice that we have a 5k here and we have a 3k. Those are like terms, right? So we can move those just like we do like the 2 and the negative 6. So normally you would say minus 2, move it to the other side, right? And then that leaves you with 5k equals 3k, and then that would be minus 8. That's normal. That's something we do all the time. We've been doing the last 2 learning targets. But now I can actually do the same thing with values that have variables attached to them. I can move them from one side to the other, just like you did to the negative 2. So 3k is positive. So if I wanted to move it to the side where the 5k is, I could subtract 3k to both sides, and then that gets me 5k minus 3k, which is 2k. And then because I had a positive 3k minus the 3k, those cancel each other out, leaving you with 0. So 0 minus 8 is just negative 8. So now combining those like terms allow you to be able to isolate the variable like you would in any other solving problem that we've done so far. So then the only thing I have left to do here is to divide both sides by 2. And that gives me k equals negative 4. Okay? Done and done. So example 2, same idea. Now here 2.8 doesn't have a like term on the other side, so I'm just going to leave that. So first I'm going to combine my like terms of 3.3c and 1.3c. Now because 2.8 is on the right side, I'm going to leave it, so I'm going to choose to move the thing on the same side as 2.8 to the other side, which is this 3.3c. Okay, so that means I subtract it from both sides. 1.3c minus 3.3c is negative 2c. And then from there, I want to divide both sides by what's being multiplied to c, which is negative 2. So then allows me to get negative 1.4. Okay, and that would be my answer. Okay, so now they're going to start involving some parentheses here. So kind of like order of operations, I want to deal with that. So I'm going to use the distributive property. So that means that 3 gets multiplied both to the 6 and the negative 2x. So that means I get 18, because 3 times 6 is 18. 3 times negative 2x is negative 6x. Okay, I bring the other terms down because I haven't done anything to them yet. And so now I have the same setup as what I had in example 1. So now here, let's say I want to put the x's together first. That just means I'm going to add 6x to both sides. 8x plus 6x gives me 14x. I didn't do anything with the minus 10, so I just bring it down. 18 still there. Negative 6x plus 6x cancel each other out, leaving you with just 18 on the right. So then now, this is just like a normal 2-step equation, where I'm going to add 10 to both sides, because it's being subtracted. That leaves you with 14x on the left. 18 plus 10 on the right gets you 28. And then, because 14 is multiplied to x, I'm going to divide both sides by 14. So that leaves you with x equals 2. And that's your answer. Okay. Now, example 4 is a little bit of a step up to example 3. It's because you have 2 parentheses, so that means you have to distribute for both of them. Okay. So first I'm going to take the 6 and times it to the 5m, which gives me 30m. 6 times negative 3 gets me negative 18. Okay, now here, 1/3 times a number, it's like dividing, so it's really like 24 divided by 3. So 1/3 times 2m, or 24m, would be 8m, because 24 divided by 3 gets you 8. And then 1/3 times 12, which would be 4, because 12 divided by 3 would be 4. And now I have that same setup as I had in example 3 and 1. So here, let's subtract the 8m to both sides, so we can get those like terms together. That gets me 22m. Bring down my negative 18. Bring down my 4. That 8m minus 8m went away. Now I want to move the 18 to the other side. So since it's subtracting, I'm going to add. And then that leaves you with 22m on the left. 4 plus 18 gets you 22 on the right. And then because 22 is dividing or multiplying to m, I want to divide both sides by 22. So m equals 1. And those are my answers. Okay, pretty simple, pretty slick. Okay, let's move on to the next 2 problems. Now here, sometimes there's a couple things that might show up when you have variables on each side. And it's this idea of whether you could have a no solution, so like no answer, or the idea that no matter what variable or number I put in for my variable, I would always get a correct answer no matter what. So let's kind of take a look at these. So the thought of solving here is exactly the same. There's no difference between what we just did to right now. So let's keep on going with how we've been doing stuff. So here I see parentheses, so I'm going to distribute the 3 to both the 5n and the negative 4. I'll bring down the rest of this good stuff. So 3 times 5n gets me 15n. 3 times negative 4 gets me negative 12. And I bring down the minus 10n. Now, I see that 15n and minus 10n are on the same side, right? So I'm going to combine some like terms on the same side. So 15n minus 10n gets me 5n. I haven't done anything on the left, so I'm going to leave it. Just keep the same. 15n minus 10n gets me 5n. I didn't do anything with the negative 12. Notice that the minus 12 stayed the same. I didn't lose the minus. I didn't change to 12. I just kind of like skipped the negative 10n. So kind of like ignored it almost. So that I could put 15n and 10n together. So then now, kind of like what I've done before, I want to put my n's together. So I see that 5n is on one side. So I'm going to move it to the other side. Okay, so then now this is a curious thing that happens, okay? Here you have 5n minus 5n on the left. Those cancel out, leaving you with 5 on the left side of the equation. Then 5n minus 5n happens on the right as well. So they cancel each other out, leaving you with negative 12, okay? So you have no more variables. What do? Is it wrong? Is it right? What's the answer, okay? Well, sometimes when our problems have variables on each side, sometimes they cancel each other out because they're actually going to line up and be the same values. So what we have to look for is the statement at the end. So here, does 5 equal negative 12? Well, I know that 5 is not the same as negative 12, so they're not equal, okay? So if they're not equal, that means that there is no solution to this problem. And that is my answer. Okay, there's no answer. So there's nothing that I could plug into the original equation for this to ever work. And that's just how it's going to be, okay? And so that's a fine and okay answer sometimes. Okay, let's try the other one. So example 6, same idea. I see there's parentheses, so I'm going to distribute this 3 through. So 3 times 2b gets me 6b. 3 times -1 gets me -3 minus 7. And then 6b minus 10 on the right. Oh, I see -3 and -7 are on the same side. They're like terms, so I'm going to put them together. So -3 minus 7 is -10. Okay, so hopefully now you kind of start seeing what's going on here. I'm going to combine my like terms, so 6b, I'm going to move it from one side to the other, just like I did with the 5n in the last one. Now same thing happens, 6b minus 6b cancel each other out, leaving you with -10, right? On the other side, 6b minus 6b cancel each other out, so it leaves you with -10. So then now, look at your statement. Does -10 equal -10? Well, I would say yes, they're the same number, right? So because they're the same number, they do equal each other. So this one, we would say checks the box, and we would say that no matter what value you plug in to your variable of b in this problem, it means that all real numbers work. Okay, so all real numbers or values are answers to this problem. So you have infinitely many answers for this equation, and that's kind of a crazy thought, but it's very true. Okay, so that's kind of what you're looking for with those two. So when it's no solution, you get a statement at the end where the numbers aren't the same. For all real solutions, that means that you got a statement at the end where both numbers were the exact same number. Okay? And that's what you need to look for learning target 4. Okay? Have fun.